This lecture provides a short introduction to linear inequalities and notations that we'll need to solve these types of problems. A linear inequality in one variable is an inequality written of the form ax plus b less than c, where a, b, and c are real numbers. Now, we could have any of the four inequality symbols here: less than, greater than, less than or equal to, or greater than or equal to. What we need to really understand is, what does an inequality mean? What does the statement x strictly less than 8 mean? Taking a look at the number line, and the number line is made up of all x values. If x is less than 8, that means that I want all of the values less than or smaller than 8. We know that smaller numbers are farther to the left on the number line. So right here is 8. I want values that are smaller than 8. So that would be all of these numbers to this direction. And I'm putting an arrow here to indicate that I want to keep going forever. I need to introduce a notation here that we're going to use when graphing inequalities on the number line. We want to use a parenthesis anytime we have a strict inequality, and we're going to use a square bracket anytime we have an or equal to inequality. You might have seen a slightly different notation before. I know when I first learned this in high school, that when it was a strict inequality, we used an open circle. And when it was or equal to, we used a filled in, a solid circle. So it's the same idea, but we're making a change in notation. So if I were actually graphing x is strictly less than 8, I've shaded the correct direction, and now I just need to put the proper notation at the endpoint to indicate that I'm not including 8. Since it says I'm not including, I want to use a parenthesis, and I would draw a parenthesis. A couple other notations that we're going to use are called interval notation and set builder notation. Interval notation is used to represent a non-stop range of values that satisfy an inequality. Anytime you're writing interval notation, you want the smallest value first and then the very largest value second, with a comma in between. It's possible that we might say something that, oh, the ages of our friends range between 18 and 27. We might write it this way. It's kind of the same idea of interval notation. You start with the smallest number first. Instead of using this dash, we're going to use a comma and then the largest value second. The only other things we need to do is write either a parenthesis or a bracket to indicate whether we're including the end value or not. Please note that negative and positive infinity always get parentheses. It's not an attainable number, it's more of a concept, so they're always considered not included. Set builder notation, a lot of it always starts the same. The set of all x such that. That's how we read this. These squiggly braces here are set brackets, which mean the set. The x that we see tells us the set of all x. The vertical line means such that. Some people choose to use a colon instead of a vertical line to mean such that. This part of the set builder notation always stays the same. What's going to change is the condition. And that tells us, well, what kind of x are we interested in? X's that are less than 8, X's that are greater than or equal to 0. What X's are we talking about? Let's graph X is strictly less than 8 and then write the solution set in interval and set builder notations. We graph this above already. I need to find 8 on the number line. There it is. We want to graph X is strictly less than 8. Less than is to the left, so I'm going to shade to the left. And make sure you put an arrow on the end to indicate that shading keeps going. Since it's a strict inequality, we want to use a parenthesis at 8 to indicate that we're not including. Now we want to write the other notations. With the interval notation, we want to start with the very smallest number represented with the shading. Smaller numbers are further to the left, so we look to the left, and I see an arrow. That arrow tells me to go forever to the left. The number that's forever to the left is negative infinity. As mentioned above, negative infinity and positive infinity always get parentheses. So we're going to write a parenthesis here, comma. Now we want the very largest number in our shading. The very largest number is right before 8. The way that we're going to write that is 8 with a parenthesis. That parenthesis says we're not including 8. That gets us right up to 7.999999999. The set builder notation, well, it always starts the same. The set of all x such that. The only thing that changes is what we have after the vertical line. What x are we interested in? These x that are strictly less than 8. That's what goes after our vertical line in our set builder notation. Let's do one more. I want to graph x is greater than or equal to -3 and write the solution set in interval and set builder notations. Start with my number line and -3. I want x to be greater than or equal to -3. The greater numbers are located to the right. I'm going to shade to the right and put an arrow to indicate that my shading continues forever. Before I move on to my notations, I need to look at my inequality symbol and decide whether I'm using a parenthesis or a bracket. Since it's or equal to, I'm going to use a square bracket. I always remembered that the square brackets went with the or equal to inequality symbols because they both have this horizontal line at the bottom. There's my graph. Moving on to my notations. We'll do interval first. Interval notation, we want to start with the very smallest number we have represented in our shading. That very smallest number is -3. Since it's or equal to, we want to indicate that we're including it. We do that by using a square bracket, just like we did in our graph, comma. Now we want to put the very largest number represented with our shading. I look to the right, since that's what larger numbers are, and I see an arrow, which tells me to go forever. The largest positive number, as I'm going forever to the right, is going to be positive infinity. And as we've discussed, Infinity always gets a parenthesis. Set builder notation always starts the same. It's the set of all x such that, and then some condition. The condition that we have this time is that x needs to be greater than or equal to -3. So that's what goes to the right of our vertical line in our set builder notation. We have the set of all x such that x is greater than or equal to -3.